Pre-calculus, chapter 1, lesson 2, we're going to do some examples of determining the horizontal and vertical asymptotes. For my first example here is 2x minus 4 over x squared minus 4. So let's do the horizontal asymptote first. The horizontal asymptote is found by looking at the degrees of the numerator, polynomial, and denominator. So the degree of this is a 1. We're looking at the exponent of the highest exponent of the variable. So this is a first degree in the numerator, a second degree in the denominator. Because the numerator degree is less than the denominator degree, my asymptote is at y equals 0. So my end behavior or horizontal asymptote is at y equals 0. The vertical asymptotes are at the zeros of the denominator. So you'll want to find the zeros, and you can do this. This is a quadratic. How do you find the zeros of a quadratic? Factoring, complete the square, quadratic formula, graphing even if it doesn't factor. So this one factors though into x plus 2. It's the difference of 2 squares, x minus 2. So then we look and say, okay, what makes this 0? Negative 2. And what makes this 0? 2. So these are the zeros of my denominator. So my vertical asymptotes are at the vertical line at x equals negative 2 and the vertical line at x equals 2. Now you could write this as x equals plus or minus 2. That would be okay as well. So these are my horizontal asymptotes, or this is my horizontal asymptote, and these are my vertical asymptote. Now I'm going to make a very important point here. You must always, 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 always give me the asymptotes as equations of lines. Asymptotes are lines. Therefore, the answer must be the equation of a line. Y equals 0. Y equals any number is the equation of a horizontal line. So your horizontal asymptotes should always be y equals some number. And x equals some number is the equation for a vertical line. So your vertical asymptote should always be x equals some number. If you do this, I guarantee you I will mark you wrong. Not because I'm being a jerk, but because I'm telling you, it's the equation of the line. Asymptotes are lines, so your answer should be a line. If you write the horizontal asymptote at 0, or if you write horizontal asymptote equals 0, or something like that, this is not the equation of a line. Asymptotes are lines. Your answer needs to be the equation of a line, so write me the equation. Okay? Do not leave it like this. I'll have to mark you wrong, and I will take no pleasure in it. I just have to do it because that's what I said I would do. Okay? Alright, so let's look at another example. Oops. There we go. 4x minus 4 over x cubed minus 8. So, let's do the horizontal asymptote first. The degree of the numerator is a 1. The degree of a denominator is a 3. Numerator degree less than denominator degree, so my horizontal asymptote is at y equals 0. Okay. Vertical asymptote is at the zeros of the denominator, so I need to know what makes this 0. It's not a quadratic, so it doesn't really factor. So we could use some algebra, and we know we can say, well, I don't want that to be equal to 0. And then just solve it like we did this. So you take the cube root of each side to uncube that. Cube root of 8 is 2. So my vertical asymptote, the number 2 would make this denominator 0. So my vertical asymptote is at x equals 2. Again, the equation of a vertical line. Okay? Alright. Let's do another one. Bye. Hello. Next one. Tricky one, just so you know, tricky one. Now, you're looking at this numerator and this denominator. We want to compare the degrees. Now, if things aren't in standard form, this is tip of the day, tip of the year, as a matter of fact. Well, maybe not the year. Tip of the week. All right, tip of the week. It's always valuable to you to, before you start doing anything, is to make sure that this is in standard form. In other words, put your numerator in standard form and put your denominator in standard form. It'll make things a lot easier as you go down the road here. So just a tip, something I would do. And I'll show you why, because I'll show you the mistake that you'll make here in a moment. So the degree of this is a 1. The degree of this is a 1. The degrees are equal, which means my asymptote is y equals the leading coefficient term, the leading coefficient of the leading term, the coefficient of the leading term in the numerator goes here. So this is a 1, so my numerator is a 1. The coefficient of the leading term in the denominator goes here. This is a negative 1. So y equals negative 1 is where my horizontal or end behavior asymptote is. Now notice what will happen if you don't put it in standard form. I guarantee you somebody will do this. Even though I'm telling you to watch it, somebody will do this. And I have a name in my head right now. Do you know who it is? Interesting. I won't tell you because that'd be embarrassing. You're going to say, okay, well, here's a 1 and here's a 1. They're both degrees, so I take the leading coefficient of the first number here, and that's a 3, so my asymptote's at y equals 1/3. That's what you'll do. But it's not just the number that's in front. It's the leading coefficient. It's the coefficient of the leading term. And the leading term needs to be front in standard form. If you do that, you'll avoid this error, so don't make it. Just a tip. Tip of the week. Do what you want, but I know somebody's going to do that. But please don't. Don't be the one. Okay, last one real quick. The degree here is a 1. Degree here is a 1. So I take the coefficient of the leading term here, which is a 1, over the coefficient of the leading term here is a 1. So y equals 1 is my horizontal asymptote. And you should, as a matter of practice, label this too. Horizontal. And then what makes the denominator 0 is a 0. So my vertical asymptote then would be at x equals 0, my vertical line. Okay, so those are some examples. If you need more help, then ask me in class, or we can do some more examples for you.